All right, mathematicians, Mr. Antonucci back today with another video. And in this video, I want to talk about how to multiply radical expressions. All right, so it's going to be a good one. All right, guys, so we've talked previously about the product property for square roots that says if you have square root of a times b, you can rewrite that as square root of a times square root of b. Well, the property actually works both ways. If you have two square roots being multiplied together, you can multiply the radicands, the numbers inside the square roots. Okay, so let's look at two examples here to just illustrate what we're talking about. If I have 2 square root of 3 times 4 square root of 6. Okay, how this works is when you're multiplying radical expressions, you multiply the numbers out front and then the numbers inside. Basically, that's what we're doing. So you'd have 2, let me do it like this. You have 2 and 4, so you'd have 2 times 4, and then square root of 3 and square root of 6 would be square root of 3 times 6. Okay, so now 2 times 4 gives you 8, square root of 18. Okay, so you have to be careful here though, because once you multiply radical expressions, you may end up with a number in the radical that contains a perfect square factor. So it might not be fully simplified at this point, even though you did a step of simplification. So just follow the previous things that we've talked about. Square root of 18 can be thought of as 9 times 2. I know it can be thought of as 6 times 3 or 3 times 6. That's where we got it from. However, those don't show the perfect square factors. So I want to rewrite 18 as a product that shows the perfect square factor, 9. So square root of 9 is 3. That's going to come out and multiply the 8 that's already there. Okay, and then 8 times 3 is 24, square root of 2. And that is fully simplified, folks, because I don't have any perfect square factors inside the radical. And then the other two conditions are that you can't have any fractions inside the radical or any radicals in the denominator. We've talked about those in a previous video, and there's no fractions here, so it's not really applying. Let's do one more example. What if I had example number 2, 3 square roots of 5 times 4 square roots of 5 plus 2 square root of 15. Okay, so in this example, which should pop up in a second, there it goes, we have addition inside parentheses. Now, you could try to add those together, and I'll just tell you, in this case, it's not going to work because 5 is a prime number. You can't get any perfect square factors there. And the square root of 15, 15 is just 3 times 5. Again, no perfect square factors, so you can't simplify those. You cannot add the 4 and the 2 together to make it 6 square roots of, I don't know, sometimes people would add the 5 and 15 and get 20. You can't add inside you can't add radicals together that are not like radicands, okay? But you do know the distributive property. This 3 square root of 5 can distribute here to the 4 square root of 5, and that's just multiplication. So that ends up being 3 times 4, and then square root of 5 times 5. And then it also distributes to the next term. If we had 3 terms, 4 terms, 5 terms inside the parentheses, you would just keep distributing the 3 square roots of 5 to each one of those. So that's going to be 3 times 2 square root of 5 times 15. Okay. So now 3 times 4 is 12 square root of 25. And I know the 25 is perfect square, so we'll get to that in a second. I just want to show you each step. 5 times 15 is 75. Okay, now square root of 25 is 5, so that's going to be 12 times 5, and there's nothing left in the square root, so you don't like write a square root symbol that's empty. You just basically you took the square root of 25, you completed that operation, so the answer to that piece is 5, and it's going to multiply the 12. Okay, now square root of 75 can be thought of as 25 times 3. Okay, because 25 is a perfect square factor of 75. Okay, let's clean this up. 12 times 5 is 60. Plus, now let's do two steps at once. The square root of 25 is 5. That's going to come outside of the radical and hit the 6 and multiply it. Okay, so that gives you 30 square roots of 3. Now we're done. There's no more we can do. Okay, the 60 and the 30 cannot be added together because they are technically not like terms, because the 30 has a square root of 3 with it and the 60 is just sitting out there. Okay, so it's 60 plus 30 square roots of 3. That, ladies and gentlemen, is our final answer. All right, guys, so hope that was helpful to you. And if you have a question that you'd like me to do, math problem that you'd like me to make a video of, put it in the comments below, and maybe I'll have some time to make a video about it. And while you're there, make sure you subscribe to the channel, hit the bell for notifications when new videos are uploaded. All right, Math Ninjas, make it a great day. Antonucci out.